I hope you remember that I've already mentioned to you in the last class that one method of converting any game which does not have any saddle point to a 2x2 game. Because as I mentioned to you in the last class, that if a game does not have any saddle point, that means the game have the mixed strategies. And if you want to find out the solution of any mixed strategy game theory problem, then obviously you have to convert that game problem or payoff matrix into a 2x2 game. And to do that, in the last class, we have discussed one method. Now, today, we are going to discuss another method. And the rule is that dominance principle. Remember that for the dominance principle, one thing is very important. The thing is that, as I mentioned to you initially, because that is actually tone the set of that set the tone of that solution. How we are doing the solution. A is always try to increase his profit, and B player is always try to minimize his loss. That means A is always a gainer and B is always a loser. But that means if A is the gainer, A, what will try to do? A will try to definitely maximize his gain. And B, what will try to do? B will try to definitely minimize his loss. That is the concept. And based on this concept, we are going to apply this dominance rule. Let's see what is the dominance rule says. That, as I mentioned to you, that this rules is used for evaluation of 2% zero-sum game. I have mentioned to you that here, what are the problem we are going to discuss? Every problem is a zero-sum game. Okay. So, without saddle point, that is without equilibrium point, certain dominance principles are stated as follows. What are the dominance principles? For player B, who is assumed to be loser, if each element in a column, say CR, is greater than or equal to the corresponding element in any other column, say CS, in the payoff matrix, then the column CR is said to be dominated by CS. And therefore, CR column can be deleted. What is the meaning of that? Suppose that if I consider a game of suppose that 3x3. Okay. So suppose 3 strategies B also have and A also have the same number of strategies. Now let us consider C1 and C3. 2 column I am considering. So as player B try to minimize his loss, that means a player B always try to keep the minimum payoff in the payoff matrix. Minimum value in the payoff matrix. That means if C1 is less than equal to C3, that means for the player B, C3 is not required actually. For player B, as player B is try to minimize his loss, so player B will always try to keep the column which have the minimum payoff. Clear? Which have the minimum payoff. So that means for the player B, it is always better to delete that column. And that is actually mentioned here. You can see that it is given that then the column CR is said to be dominated by the column CS, and therefore CR column can be deleted. CR is greater than equal to CS. So now if I ask you the same thing for the player A, what you are going to do? Suppose for the player A, I have R1, R2, R3. 3 rows are there. So player A, what will try to do? Anyone? Player A always try to keep that row which have the maximum value. So now, if I am considering 2 row R1 and R2, and suppose that the relation between R1 and R2 is like that, R1 is greater than equal to R2. Then as the row defined for the player A, that's why for the row, I am going to delete the minimum row. For this relation, you can easily understand that R1 as R1 is greater than equal to R2. So in this payoff, R2 has the minimum, and A as A try to maximize his profit. So that's why A will always try to keep that R1. Is it okay to all of you? Yes, R1 is greater than equal to R2 means basically each element of R1 will be greater than equal to each element of R2. C1 is less than equal to C3 means each element of first column is less than equal to each element of third column. Now, it may not happen that every element of R1 and R2 satisfy this relation. Or it may not be happen also that C1 and C3, every element of C1 is satisfying with this relation with C3. In that case, we cannot apply this rule. We cannot delete that C3 here. We cannot delete R2 here. So there is another rule which can also be applied like that. That suppose R1 and R2 are not satisfied with the relation R1 is greater than equal to R2, but convex combination means if I consider lambda 1 R1 plus lambda 2 R2, where lambda 1 plus lambda 2 equal to 1. Right? That means sum of the coefficient of R1 and R2 is 1. So if the convex combination of R1 and R2 is greater than equal to R3, remember that. If it is greater than equal to R3, then also the third rule says that then also we can delete R3. Clear? That's why it is written. If the ith row be dominated by a convex combination of the other rows, then ith row is deleted. That is actually happening here. Now, for as I mentioned to you, for row, always we try to keep the maximum value, and for column, always we try to keep the minimum one. So in that case, what should be the relation? We are going to take C1. If I take that C1 is what? Greater than equal to lambda 1 C2 other columns, right? So lambda 2 C2 C3. If it is happening, then what is going to be happen? We are going to delete the column C1 because for player B, what player B always try to do? Player B always try to keep the minimum payoff in the matrix. Please try to understand this thing carefully because these theoretical terms will be written in the book. And what I am explaining here, it is the simplest version. How you can remember that also you can understand. Is it okay?
Yes, sir.
Now, okay. You have to understand that anywhere, if you find any doubt, you please ask me. I'm going to repeat it again and again, but you have to understand. Because you have to solve in the exam actually. Now, another thing is there, which is called as the modified dominance principle, and we are going to use this property when it will be when this 3 is not applying anywhere. If this 3 is not possible to apply anywhere, then we are going to apply this modified dominance property. What is that modified dominance property says? Suppose that what I mentioned to you, that lambda R1 and lambda 2 R2 is greater than equal to R3, then we are going to delete R3. But if this is not greater than equal to R3, and suppose that this is less than equal to R3, then we cannot delete R3. Remember that. Right or wrong? What I mentioned to you, because as I mentioned to you that ith row is dominated by the combination, but here it is not dominated by, because it is bigger than R1 and R2 convex combination. In that case, modified dominance principle says that we can delete any one of the strategies R1 and R2. But remember that the game solution must exist after deleting that row. That means it may happen that after deleting R1 and if you consider R2, you may not get the solution. Solution means the strategies what we are getting, it may be negative. If the strategies are negative, strategies are cannot be negative because it represents the probability. So that's why in that case, you have to consider R2 then. After deleting R1, if you do not get the solution, then you have to delete R2 and you have to proceed and you have to solve this game theory problem. Okay to you what I'm saying? Yes, we can delete any one R1 or R2, but the game solution must exist. So after deleting R1, if you do not get the solution, means what? What can be happen? That any one of the probability may be negative, x1, x2, or x3, or y1, y2, or y3. Any one may be negative. If it is negative, then it cannot be the solution. So in that case, we are going to try with R2 then. Clear? After deleting R2, if it is not possible to solve, then we have to try with R1. This way, this process occurs. Same thing happened for the column as well, that if C1 is not greater than equal to, suppose that C1 is less than equal to lambda 1 C2 plus lambda 2 C3. Then also in that case, you cannot delete C1. In that case, what we are going to do? We are going to delete any one of the column, either C2 or C3. And again, provided the solution must exist. This is actually the dominance principle. If you have any question, you please ask me. Please. Any question if you have, please. Okay. So now let's proceed to solve a problem. I think if you solve the problem, it will be easy for you to understand that how we are going to find out the solution of this kind of, if you want to apply the dominance rule. Now, obviously, till now we have not solved any kind of problem where actually we have created the P of matrix. Each and every problem we have seen that P of matrix was given to us. But now we are trying to solve a problem where the P of matrix we have to create, and then we are going to solve the problem. What is that? Players A and B play a game in which each has 3 coins. A has 3 coins, B also has 3 coins. And the coins are 5 paisa, 10 paisa, and 20 paisa. Each selects a coin without the knowledge of the other choice. As I mentioned to you, that they don't know what kind of strategies they are playing. They are playing a game, and they don't know what other playing. What other is choosing that which coin. So each selects a coin without the knowledge of the other choice. If the sum of the coins is an odd amount, then A wins B's coin. That means A will get B's coin. If the sum is even, then B wins A's coin. Find the best strategy for each player and the value of the game. Is the question is clear to all of you? Okay. Now first come to that. As you can see that I have written strategies B1, B2, B3 for the player B, and for the player A, I have written the strategy as A1, A2, A3. So if the sum is odd, then A wins B's coin. And as I mentioned to you at the first class, that when we are writing this P of matrix, we are writing it for A. That means positive entries means that A will get those, and negative entries means B will get those, right? So as the sum is even here, if player A plays A strategy, player B plays B1 strategy, then the sum is 10. And as sum is even, then B wins and B wins A's coin. So how much B will get? So how much B will get? What will be the entry here? B wins A's coin. A's coin is what? 5. So B will get that 5 paisa. That means the entry will be -5. Because I have mentioned to you that this P of matrix represent the player A. So positive entries means that the player A will get those money, and negative entries means A will lose those money, that is B will get those money. Now next, tell me, what will be the entry here? A1 5, B2 5, 10. What will be the coming here? Yes. The sum is 5 plus 10. That is 15. 15 is odd or even? Odd. And if odd, then what is going to happen? A wins B's coin. So that means A will win here. And how much B's coin is there here? 10. That means here the entry will be 10 plus 10. Okay. Similarly here, tell me now that this entry A15 B310, what will be here? B320, what will be here? 20. Very good. What will be coming here? A2B1? No. Only 5. Only 5. Because it's odd. Odd. Yes, 5. This one? Minus 10. Very good. This one?
minus 2.
Very good. Very good. 25. Sure? Yes, 5. Yes, 5. Very good. Yes, yes. 2010. Very good. 2020. Very good. So this is your pure matrix. It is easy, very easy, but if you understand the thing. Okay, now although the question has not asked to find out the solution by using the dominance principle, but we are going to use the dominance principle because as I mentioned to you already, that if you want to apply the graphical method, then the pure matrix would come with either 2 cross n or m cross 2. This is not fall any one of that case. That means we have to use the dominance principle to find out the solution. But before that, always we have to check whether the saddle point exists or not. Because graphical problem or dominance principle, that methods is only applicable for the game which does not have any saddle point. So what we are going to do? First, what I mentioned to you, we are going to find out the maximin principle, right? And minimax principle. Remember that, right? Right? So what you are going to do first? First, we are going to find out the minimum of the row and maximum of the column. So minimum of the row is what? Minus 5, minus 10, minus 20. And maximum of the column is what? 5, 10, 20. Then what you are going to do? You are going to find out the minimum of here, that is 5. And we are going to find out the maximum of here, right? And maximum is minus 20. So you can see that min max is not equal to maximum. Right? Right? So maximin is not equal to min max. That means the game does not have any saddle point. So the game does not have any saddle point. So now what we are going to do? We are going to apply the mix strategy. So we'll proceed to find out the mix strategies. And if you want to find out the mix strategies, the method, what I mentioned to you, we are going to apply is dominance rule. So for the dominance rule, what we are going to do? We are going to see that whether any row is dominated by any other row or whether any column is dominated other column or not. Right? Clear? So now, if you look at that, B1, B2, B3, have you find out that whether any column is less than equal to or greater than equal to any other column? Anyone? Okay. If you look at B2 and B3, देखो, this 10, 20. That means this is less than equal to, this is less than equal to, this is less than equal to. That means each element of B2 is basically less than equal to a B3. Right? So what you can write down? The second column This is the first question. I'm writing it for you, but you have to write down this way in the exam as well. So the second column is dominated by what? Third column, because third column is superior, right? Okay. So third column, that is B3. So what you are going to do? Which column will be deleted? For column, which column we try to keep? Remember that, that is enough. Yeah, bol. এটাকে রাখবো বি এর ক্ষেত্রে, ভেরি গুড, সেই কলামটা রাখবো, সো দ্যাট মিন্স B3 will be deleted. Yes, exactly. So hence the third column, very good, third column, that is B3, is deleted. Okay, now then if I delete that B3, then now it is transferred to 3 cross 2. So let's see. So now the resulting 3 cross 2 payoff matrix is this for the player B, this for the player A. Remember that you have to write down, right? So what will be left? Let's see. Minus 5, 10, 5 minus 10, 5 minus 20. Okay. So minus 5, 10, 5 minus 10, right? And 5 minus 20. I have mentioned to you that our aim is actually try to convert this payoff matrix into a 2 cross 2 game. So now we have already eliminated one column. Now we have to eliminate any row. And if I eliminate that, then it will transfer to a 2 cross 2. So tell me now, have we find out any less than equal to or greater than equal relation between the any two rows? Very simple. Look at A2 and A3. Very good. Yes. So now what you can write down? So we see that second row, that is A2, dominates the third row, right? Third row. Why it's dominate the third row? Because you can say that A2 is greater than equal to A3. That means which column will be deleted? Yes. So hence A3, sorry, which row? Hence A3 is deleted. Okay. So the reduces payoff matrix. Now it is transferred to 2 cross 2. So the game reduces to the following 2 cross 2 game. Right? The game reduces to the following 2 cross 2 payoff matrix. What is that? Minus 5, 10, and 5 minus 10. Now it is transforming into a 2 cross 2 game. So now you can easily apply that mixed strategy formula to find out the solution. Okay. So what we are going to do? Now we are going to write down that let x1, x2, x3, let x1, x2, x3 and y1, y2, y3. Okay, be the probabilities with which A and B play the game. So here you can see that only A1, A2 and B1, B2 left for the player A and player B, right? This for the player B, this for the player A. Okay, so only X1, X2 and Y1, Y2 will be there because X3 and Y3 is automatically you have deleted, so this part is automatically 0. So now if you want to calculate X1 now, just we are trying to do it here so that it will be easy for us to visualize that matrix. So to get X1, what I mentioned to you, how to remember, first we eliminate this row. And in this row, sorry, if you want to find out X1, first we eliminate the first row. And then we'll come here in the second row and we are going to find out the principal diagonal. What is that? Minus 10. Minus the other element, that is minus 5, this one. Okay? Divided by sum of the principal diagonal, that is minus 15, minus sum of the other diagonal, that is again minus 15. So it is basically, it is coming as minus 15 by 30, that is half. Okay to all of you? Similarly, X2 will be also same. We can do that. X2 means we are going to eliminate this second row. And in the first row, what we are going to do? Minus 5, there is a principal diagonal, minus other element, that is minus 15, and denominator is remain all over is minus 30, so that is also half. So X1 and X2 both are half. Let's calculate Y1, Y2 as well. Tell me Y1. Y second column will do it, second column, yes. না না y1 এর জন্য আমরা ডিলিট করব ফার্স্ট কলামটাকে, সেকেন্ড কলামটাকে কনসিডার করব। What will be here? Minus 10, minus 10, 2 by, and y2 you can also find out by y minus y1. That is one. And v, value of the game, we are going to write down each and everything in the next slide as well. Just I'm doing it here so that we can. So v, value of the game, numerator is what? Product of the principal diagonal, that is 50, right? Minus product of the other diagonal, that is 50 again. So 50 minus 50, that is 0. I hope you remember I have mentioned you the fair game. What is the meaning of fair game? If the value is 0, if the value of the game is 0. So this game is actually a fair game. Clear? Okay, so now what we are getting, we are going to write down this. Now x1 we are getting it as half, x2 is also we are getting it as half, y1 we are getting it as 2 by 3, and y2 we are getting as 1 by 3, and the value of the game v is 0. Okay, so the optimal strategy for player A is what? You can understand half, half, 0, and the optimal strategies for player B is 2 by 3, 1 by 3, 0, and the value of the game V is 0, which is a fair game actually, you can say. This is a fair game. When the value of the game is 0, the game is called as a fair game. Okay? So shall we proceed? Next problem? Okay. First note down the problem and then again I'll explain how to solve that. Again, we have to use the dominance property to reduce the following game into a 2 cross 2 game. And hence, you have to find out the optimal strategies and the value of the game. So the solution of the game means, remember that always, it is the optimal strategies as well as the value of the game. Okay. Yeah, here the pair of matrix, yes, here's the pair of matrix given. So now ultimately we are going to directly apply the dominance principle now, right? So tell me, would you find out any relation between any rows and any columns? No. Just see A1, 2140, and A3, 4240. So now what you can say? The elements of first row, elements of first row is less than equal to the corresponding elements of, yes, corresponding elements of third row. So which row is going to be deleted? Yes. So hence delete. Okay, hence first row is deleted. Okay, so the resulting 3 cross 4, right? Initially it was 4 cross 4, we have deleted one row, so now it is coming 3 cross 4 pair of matrix is what? So A will be deleted and rest will be there, right? So 3424, 4240, and 0408. It is going to be 3424, next 4240, 4240, and 040. Yes, okay, thank you. 0408. This is for the player B, and this is for the player A. Okay, so now again, tell me the next relation. Any define any relation between the columns? Good relation. B1 is equal to B3. And which column is going to be deleted? Therefore, discarding the column B1. We get reduce. Okay, this for the pair B, pair A. Okay, so B3 will be there. Sorry, is it zero now? Still you are seeing problem? Then anyone response? Am I
Yes,
audible?
you are clearly audible.
Okay. Then connection reach. Your voice is totally clear to me. I can listen to you properly. Okay. So now what will 4, 2, 4, right? It is going to be 2, 4, 0, and 4, 0, 8. Now, the next operation to apply. So I'm just going to cross 3. You have to delete one row, one column, transfer into 2 cross 2. Listen, find out this. The range of decision what we are getting, here you are getting 2, right? This row, here you are getting 2, 7, 3. Here you are getting 2, and here you are getting 4. So, do you find out any relation with B2 now? Half of B3 plus B4 is basically what? What is less than equal to B2, right? This combination of B3 and B4 is basically less than equal to B2. So now we are going to write down that, and we are going to discard that B2 now. So now we can see that half of B3 plus B4 is less than equal to B2. So we discard the second column. Mm. Definitely. Lambda is half here. Normally, in your case, I just mentioned to you, but you cannot say that it is always going to be happen. But in normal case, in your case, actually, lambda 1 and lambda 2 normally considered as half, and you are able to solve the problem, most of the problem. Okay. In rare cases, you have to choose lambda 1, lambda 2 other than half. In rare cases, okay. Most of the cases, lambda 1, lambda 2, if you choose half. So that's why I suggest all of you to try with lambda 1, lambda 2 as half. Okay, normally it will work out. Okay, so now if you discard that second column, what is going to come? B3 and B4 will be there. There's going to be 2, 4, 4, 0, 0, 8, right? So 2, 4, 4, 0, and 0, 8. This is for the player B, and this is for the player A. Now, any relation? Because you have to delete any one row now. Then it will transfer to 2 cross 2. Now I hope you can do it. Please. Do you find out any relation? Yes. A2 is dominating F4. No. Well, half of A3, A4. What is coming? A3 and A4 half of 2 and 4. And A2 is also same. So I can always, yes, I can always consider that this is greater than equal to A2. Okay. So what row we are going to delete? A2, right? So we discard second row, or A2 row, you can say, because here the second row means A3, but from the first matrix, what we have started, it is second row means A2. Okay. So we discard A2 row. Okay. So the next reduced payoff matrix is 2 4 sorry 4008, right? Because second row is reiterated, so 4008, 4008, right? This is for the player B, and this is for the player A. So now it is easy, because again we are going to assume that x1, x2, x3, x4, this is corresponding for the player A. These are the probabilities with which A will play his strategy, and y1, y2, y3, and y4, these are the probabilities with which B will play his strategies. That means you have to find out here x3, x4, and y3 and y4. Okay, so tell me now, x3 is what? Again the same logic. x3 means eliminate this row. It is going to be 8 minus 0, right? That is 8 divided by sum of the principal diagonal minus sum of the other diagonal, that is 12. So it is going to be 2 by 3. If x3 is 2 by 3, then x4 will be automatically 1 minus 2 by 3, that is 1 by 3. y3 means we are going to eliminate that row. We are going to consider this column, eliminate this column, B3 column, and we are going to consider this B4. So it is going to be 8 minus 0 divided by 12. That is again going to be 2 by 3, right? And y4 will come as again 1 by 3. Okay, so the value of the game V is what? Bolo? 32 divided by 12. Denominator is always same, 12. So that is going to be what? 8 by 3. Okay, and you have to write down this, remember that, because the question has asked to find out the optimal strategies. So the optimal strategies for player A is x3 and x4 will be there. So rest 2 will be 0. So 0, 0, 2 by 3, 1 by 3. And the optimal strategies for player B is similarly 0, 0, 2 by 3, 1 by 3. Okay to you? No, this is not a fair game. Now, another problem I've given to you, I'm just leaving it to you to solve it. Okay, similar kind of problem. I'm just not repeating it the same way. But here you may find that the modified dominance principle may be required to solve that problem. That's why this problem I have taken. Try it. If you find any difficulties in solving this problem, you may ask me in the next class. Okay. Now, one more thing, as I came to know that you have another class, I think, right, Devdeep? Okay. Okay. So, but the thing is that this week, as you know, that first semester and third semester exam is going on. So that's why there is no class for me actually, first semester and second semester. So I'm free. So I just want to finish the syllabus by this week. Okay. And I want to give you the assignment as well. So that assignment I'll given up to dominance principle, so you'll able to solve those problems, and I'll upload it today. And tell me how much time it is required to solve that. The problems, how much problems? 20 number of problems will be 20 at max. Okay. Well, 15 days, 15 days দিদি, 2 weeks, ঠিক আছে? তো গেট তোদের কবে? 31st, 5th ফেব্রুয়ারি। আচ্ছা, তাহলে তোদের এটা আমি 15 ডেজ দিই। আজকে মানডে, নেক্সট হচ্ছে 31st, তাই তো? নেক্সট হয়ে যাবে তাহলে 7 তারিখ। আচ্ছা, আরো 2 দিন আমি দিয়ে দিলাম, 9 তারিখ করে দিচ্ছি। ওকে, ঠিক আছে। আচ্ছা, নাও টেল মি দ্যাট when you are going to, so Devdeep, will you coordinate with the other student also and tell me time for today, for sorry, for this week? Give me a slot. মৌলিপ্রিয়া ম্যামের ক্লাসটা হচ্ছে বুধবার, বুধবার হচ্ছে 26। আমি তো সেই দিনকে ক্লাসটা নিতে পারবো না, প্রবলেমটা এটাই। আমি প্রথমে ভেবেছিলাম সেটাই নেব, বুঝেছি? হ্যাঁ, 26 জানুয়ারি আমি নিতে পারবো না ক্লাসটা, বুঝতেই পারছিস। তো ওই জন্য আমি মানে ফ্রাইডে আমার অ্যাকচুয়ালি একটা ক্লাস থাকে। মানে ফ্রাইডে আমার সেকেন্ড ইয়ারে, মানে এমটেক সেকেন্ড ইয়ারের ক্লাস থাকে। ওদের ক্লাসটা তো নরমালি ওদের মানে শিডিউল অনুযায়ী চলবে। তাই ওদের ক্লাসটা তো হবে। এবারে আমার যেটা দরকার, যদি তোরা পারিস কালকে কোনো একটা সময় বা থার্সডে কোনো একটা সময়, তাহলে বেটার হয়। হ্যাঁ, 3টে থেকে নিয়েছিলাম আমি। হ্যাঁ, তাহলে দেখ, the logic is nothing, just one method remains, and that is the algebraic method. And it will take another, as you can see, the dominance principle takes one class, and so algebraic principle also, method also take one class to finish, and that is the end of your syllabus. So I do not want to extend it that. Okay, so I want to finish this by week.